Okay, here is an interesting one. One of the first results in the option theory, which says that if the underlying pays no dividends, then the price of the European call on that underlying has to be equal to the price of the American call on that underlying. Okay? Equivalent American call. So I already know that lowercase c European price cannot be larger than the American price. It has to be less or equal. But here I'm saying it cannot be strictly less. It has to be equal. In other words, that this means that having an American option, having the possibility to exercise early European call on an asset that pays no dividends actually brings you no extra benefits. It has no value. It has no extra value. If the asset pays no dividends, having a European or an American call doesn't matter. It's the same value. Okay? There is no extra value in having the American version. Now, in practice, most assets would be paying dividends, and the European call would be strictly less than the American call. Even if it doesn't pay dividends, this theoretical result doesn't quite have to hold in practice. But in theory, in a perfect market, let's see why this has to hold in order not to have arbitrage. Okay? Same logic. Let's assume that it does not hold. Let's assume that European price is strictly less than the American price of a call option on an asset without dividends. Sell expensive, buy cheap. This one is high. Sell an American call on this asset. You're going to have enough money and some left. So you have more than enough money to buy the European version of the same call. All right. Now here's a little bit of a difference relative to what I was doing before. Now I sold this American call, so I have to worry about when it is going to be exercised if I will have enough money. Okay, so it's not only at capital T and lowercase t that I have to consider what happens. I have to consider what happens also in the meantime when the call is exercised. So let's assume that the American call is exercised at some time tau, which means I effectively have to pay S of tau minus k, right? Whatever the price, I have to deliver the stock, so I have to buy it for S of tau and deliver it. I'm getting k, so I have to pay the difference. S of t, my profit loss is the difference. Okay? But I claim I can do that by selling the European call. Why? Because in the previous slide, I showed that European call has to be larger or equal than the asset price minus discounted strike price. Now, discounted strike price is less than strike price, so with a minus sign, minus discounted strike price is larger than or equal to minus strike price. So this is just larger than S of t minus k. So this says that the price of the European call at any time is going to be larger than the difference between the asset price and the strike price. In particular, at the time of exercise, tau, this is also going to be true. So if I sell the European call that I have, I can make more, at least as much as the difference of the asset price and the strike price. So and that's going to cover what I have to pay in my American call. Yeah? I have to pay exactly that difference. I can sell the European call for more than that difference, and I'm fine. Okay. So I'm fine if the American call is exercised at some time tau. So I still have to check, the only other thing I have to check, what if the American call is never exercised. Okay? Well, if the American call is never exercised, then in the future I have nothing to pay. I have my European call. Maybe I'll get some money from that. Maybe not. Probably not, because if this one was not exercised, the European option will also not be exercised. But in any case, I have nothing to lose in the future, and I still have that extra money from the beginning. Right? So whatever happens in the future, and doesn't matter when the American call that I sold is exercised, I still have that extra money from the beginning. That's arbitrage. Okay? So, so this was not so obvious. It relies to the result that we proved previously in the previous slide. But using that result, we see that in fact the value has to be the same for the American call and the European call. Okay? So as a corollary, this means that an American call on an asset that pays no dividends should not be exercised early. Okay, when I say it this way, it seems a little bit counterintuitive, because suppose the S goes really, really high, right? So then you don't really want to wait with this American option if you're holding it, if you're the buyer, because who knows, the S can go down again, and then you will not make as much money as when it's high with the holding an American call. Well, we are not saying here that you should wait to maturity. But what we are saying is this next sentence, which says, don't exercise it. It's better to sell it than to exercise it. Okay? So you may want to get rid of it if the stock if S goes really high, but the way you get rid of it is not by exercising it, it's by selling it. Why? Because we showed that its price is going to be larger or equal than the European version, which is larger or equal than S of t minus k. So that at any time t, the American call price is going to be larger than equal than this difference. And this is what you would get as a holder of the call option. This is what you would get if you exercise it at any time at time t. But you can get more for it by selling it. The price should be higher. The no arbitrage price should be at least as much. So don't sell it. Don't exercise it. Just sell it. Right? You'll be better off. All right. So that's like a classical result for European calls on assets with no dividends. European and American have the same value. So here are two questions for you, and we'll figure them out together. First one is, what if there are dividends? Okay, suppose S pays dividends. Then I told you already that it's not going to hold. The European call is going to be strictly less than the American. But what would go wrong with this argument? Well, remember with dividends, we already discussed in the forward contract. Getting your stock in the future, you are losing the dividends in the meantime. So with dividends, the European call option is going to be cheaper than an equivalent European call without on an asset without dividends. So actually, maybe this is not going to be true. If you look at the proof from the previous slide, you have to short the stock. To prove this, we have to use the strategy of shorting the stock. But when you short the stock, you have to pay also the dividends. So there is an extra cost of paying dividends. So that argument from the previous slide, let me go to the previous slide, is this argument here doesn't necessarily work. In fact, it doesn't work with dividends. There is a version with dividends, but it's not exactly like this. Call option is not going to be this high. Okay? You will have to add the value of the present value of dividends here. So you don't really have this. You don't have a relation for. If the asset pays dividends, this is not necessarily true. The call option price is not going to be this high necessarily. So I cannot use the same arguments. I cannot use the same argument. I had to use that here. I don't have it with dividends. Okay? And in fact, with dividends, it will not be equal, and we will see later. Then even in the standard simplest models, we have to compute the price of the American option on S if it pays dividends numerically. Okay, it will. For a call option, we will have a Black-Scholes formula. For a European call option, we will have the Black-Scholes formula, but not for the American one. If the asset pays dividends, there is no formula. You have to do it numerically. All right. So that was this first question. What if there are dividends? And then the second question: how about the American put option? Do we still have this same for the put, that European value is the same as the American value? We don't. We don't for the put, and I'm not gonna show proof. I'm just gonna discuss the intuition behind it. Just switch to a ballpoint pen here. So let's look at the put. Suppose that. So when would you like to exercise the put? Right? When is the put going to have a really American put? When is it going to have a really high value? When the underlying asset S is really low, right? So suppose this is the payoff of a put, right? S T, and then 0 here, and this is K. So suppose that S comes down to here, right? So this is S. Let me write this as S of tau. So S of tau is really low, close to 0, right? So suppose, in fact, that it's so low that, suppose that S of tau is so close to 0 that K minus S of tau, which is the payoff of the put if you exercise it, suppose that it's actually larger or equal to discounted K to the e to the minus r t minus tau. Yeah, suppose this is the case. S is so small that when you subtract it from K, you get a number which is larger than discounted K. This means if I exercise here and I deposit what I get in the bank, I'm gonna get, in fact, think of this even strictly larger here, strictly larger. That means if I put it in the bank, the left-hand side in the bank, I'm going to have more than K at maturity, right? So if I deposit this in bank, meaning at a risk-free rate, I will have more than K at maturity, capital T. So if this is H here. Yeah, so if I deposit in bank, the difference when I exercise the American put, if this is the case, I will have more than K at capital T. So the value, I will definitely, the value is so high that I will definitely want to exercise when the stock is so low. Okay, and the value of the European put is not going to be bigger than K, but this will be higher than K if this happens, right? At this point, when this happens, the value is going to be higher than K. That cannot be true for the European put. So for the European put and the American put are not going to be equal in general. This is the intuition.